Hey everyone, this is Evgeny and we're back in our LangChain Unpacked series. In this series, we have a bigger block about middlewares where we taking a look at different type of middlewares, and today will be another one, but it's not so agent specific. It's more about building an application production, so it's about keeping maybe private user data, user information outside of LLM, outside of this further processing, not send this to internet. So join me and let's take a look at that together. And before we continue, I have a message for you. If you're really curious about agents and you know that the deep agent concept is on live already, right, and for some time, so we do have some courses as well where you can learn deeper way what deeper agents are. So please take a look at that, click on the link and check it on your own. And we continue. Okay, as promised, we're talking about PII middleware. It's personally identifiable information, and this is kind of not related to agents itself topic, but it's pretty important one when you're creating a real prod life application. And you don't have to put some private information to the LLM, or you don't want to show the outside world. So a lot of restrictions here, and you're really fucked up if you forget about that, right? It's not possible these days to have the app that completely ignores this stuff. Like private person information doesn't do anything with that. So let me demonstrate you something. I redefine the properties. We're going further. I'm defining a default internet search tool. Nothing really fancy here. It's just internet search, just Googling something. We define a model with GPT-O Mini and kind of the dumbest one at the moment, probably. Right, and we're creating the easy agent, and this agent has the model, it has the internet search tool, and it's very simply prompted, saying like you're a helpful assistant. Nothing really fancy here as well. And to give you some examples, let's say I have this user message, and here I'm providing really a lot of personal information. Those are the fake one. But nevertheless, look at that. I have a name of a person. I have no idea who's that. It's just randomly generated. Don't use this at all. I do have an email. I have the real card number from the credit card, and this is considered already as a private and security information. And then I'm asking to let me clear all this stuff. I'm asking to perform some actions, kind of. So I want to book a trip to somewhere, or I have an invoice to pay. And that's it, right? So what happens if I run this using our basic agent? And the first message here is that the model LLMs, they are pretty clever already. Like the dumbest one, the very simple one I used already says that I'm providing this personal information, which cannot be processed, right? But at the same time, maybe it's good, maybe it's bad, because if you think about that, we do have a reply from the LLM, which means all this data was sent already to the LLM. And for example, if you don't want your real model, or if you don't want the models to be trained with your private data, like for example, credit card numbers, you've faked already right here. You're in trouble because you provided something to the model to train. So for example, this one, look at that. It's exactly the same agent, the same internet search model, but prompt is different. And this time it's specifically saying that, okay, you're a security assistant and you have an internet search tool to provide some research. And the whole prompt kind of forces the agent to use this private data, saying kind of, okay, it's normal because this is your job to take all this data, completely ignore that it's private and do the search. So at think about that for a moment, right? Internet search means you have to send this private data to the internet. So I define this agent, and again, I'm providing the same human message with my personal data, kind of Daniel Ortiz or something, email, card number, and I'm asking to something. And it does, right? This time we even have the internet search and the query. Look at that. That's exactly what I was saying about. We have a query which contains personal email address, which contains the credit card secret number as well. And this was sent somewhere to internet, like, I don't know, maybe someone is listening to that, but this information can be saved already and used, like for hacking, for phishing emails or something. All right. And let's take another example. Kind of, I got an email from someone saying that my Netflix account is kind of being suspended if I'm not activating my credit card numbers or something. And this is real typical phishing email, forcing me to go to a site which has no relation to Netflix and provide my information there, right? So this is the email, kind of. It's generated. It's not the real one. No worries. And then I'm asking, so please, could you do the search, because I'm really worried about that. Maybe I really have fears that my Netflix account can be closed. And look at that. There's internet search for, again, the website. No, it's an email address, the credit card number, the URL as well. And finally, we have an advice back, right, that this is a phishing email, right? We have some alerts and suspicious links and advice. So practically the final word would be, I strongly advise you not to click on the link. So everything is fine. But again, we do have the same set of problems, because the data, the private data from the user, in this case, this is a security credit card number, and email was used to train the model, and you don't want this. And the query, so we send this information to internet as well. Even our security advisor still sends a lot of private information to internet. This is not acceptable at all. That's the point here, right? And ta-dam, we are going to middleware, and LangChain provides specific middleware that you can use to sort these things out somehow. And there are a number of ways, but basically what you have to do, it's called PII middleware, and have a lot of parameters. Like here, first of all, what you need to do, what you need to understand, the middlewares, it's kind of stacked one to another, and practically you can reuse the same middleware with different parameters and several times, and this is totally fine. They are not aware of each other, they just perform their job, so you can stack them on top, right, of each other. And for that, I'm defining three middlewares, all three of them the same class, like, right, and different parameters. And if I go there, but what I can see here, that there are even built-in types what can be recognized. So this emails, credit card informations, API, and MAC addresses, URLs. There are a number of strategies, like you can completely block the execution, you can redact it, mask a hash. And here you have some strategies, which one should be used when, right? Like, for example, redact is a general compliance kind of. If you have an agent, think of it as you have an agent and you work on something where you process the information and provide a response back. But this exact information should not be shown to the user, but it can go to the logs. You don't want this. It's generally, it should be hidden, so you can use this strategy. If this is human readability, meaning you show the answer to the user already, like for example, a chatbot, then probably mask is your strategy. And for some kind of analytics or debugging, you can use hashing information, because then you're able to distinguish, for example, it says, well, it's deterministic hash, meaning that the same email will have the same hash all the time. You can look through the logs and do your debugging stuff, right? And also it's possible to have some specific stuff outside of these types, like you can create a detector, regex, variable, etc. So a lot of possibilities. But for now, we will try very simple things just to give you the general thing, how it works. And what I'm going to protect this email, strategy, credit card, and URLs with different strategies. So for email, I am doing this redact. For credit card, it should be masked, and URL, it's a hash, right? And also you have different choices where to apply this. So basically, we talked about this already. You can forbid to send this, you can forbid this practically in input already. So it will be hidden before the LLM sees it. So it's not possible for them to train from this data. You can apply this to the output, and this for showing user or sending messages to log or something. Or you can apply it to tool results. So whatever tool result provides back, it can be filtered out by these strategies, right? So we have a list of three middlewares for email, credit card, and URL, and we create our agent. And here, this is the only difference, right? We're providing this stacked list of three middlewares for personal information. And the rest is the same. And this time we can try the same query. So I got a mail from Netflix, kind of, that my account can be obsolete or closed. I'm really worried. I'm providing my credit card information here just to be sure that, hey, please help me. I'm really worried. I'm really afraid of everything, right, and asking the same agent to help with that. But this time we do have these three middlewares. So let's take a look if it's different strategy, like if it works different this time. So what do we have the initial message, then we have a tool call. No, let's start from the first message, because we do have already some rules applied to the input. Look at that. The credit card was hashed. No, it's masked, right? It's with asterisks. So it's not possible even to know the real credit card. So what I recognize here. And well, here again, and here again, and here again, right? So it's hidden already. Whatever will be sent to the model, it's not possible to train this with your real car information. It's really big plus, right? Then the tool call, and this is what I meant, right? Also, the tool call doesn't know, has no idea about the real card number. So this one is hidden. And based from the tool call result, look at that. This is clear, right? Because tool didn't know already the number, but the URL was hashed. All the URLs, look at that. They are hidden now at the moment, like email verifications, URL hash. This is how it looks like, right? And then we have the response from AI agent, and look at that. Based on my search, the email you received from, and the email was hidden even. So it's like, sorry, you're not allowed to see it. And some information. Practically, it's the same, more or less, advice at the end, right? This is a phishing email. Well, it's a really good question here. If you kind of hide everything, that what would be use of this agent, like without having any real data, how can I propose you something? How can I check that this is a phishing email, for example, known on the internet or something else? So this is a matter of configuring, because it's kind of finding a way what's allowed, what's not, right? Because from one side, you're in a situation when you're not allowed to provide some personal data to LLM, to different tools as well. Maybe you're not allowed to show it back because of private information. So, for example, it could be that if this is a hack attempt trying to extract from the model some really security data, maybe you should be safe here as well. From the other side, you still have to provide some bare minimum of the information to analyze. Otherwise, your agent is for nothing, right? So it's kind of finding the right path here. But this middleware is here for helping you being protected in a certain way. Okay, that's it for this video. And the next video, I think we will switch to more interesting middlewares, and practically we'll take a look at some that can help you building deeper agents. And again, if you don't want to wait until then, if you want to have more comprehensive information, we do have some courses, so please check the link below, it's there. And it was me, Evgeny. Thanks a lot for sticking with me till the end. I really, really appreciate it. And we'll see each other next time in the next video about LangChain, Run Graph. Thank you. Take care, and bye-bye.